Assalamu alaikum. In this video I'll be demonstrating my lab 4, in which first task we have creating a digital stopwatch. So here's the code for the digital stopwatch, in where I have created six ports as output, two ports for two segment 7 segment displays representing hours, minutes and seconds. So we need 7 segments displays. For that we need 6 individual ports. Then here I've created an array in which I have written the ASCII values of all the numbers from 0 till 10, 0 till 9 basically. So and then I'm running a loop according to the time. So first of all, at port K we can see that the loop is being initialized from 0 till 9, and as port K is the most highest order display, which means it will display the hours, so we cannot go from further than 24 hours. So I have given a condition that if h equals to 2 and I equals to 4, which means basically the first and second 7 segment displays are at 2 and 4, then we break and we end the our code. And if this and instead of this, if these conditions are not met, we continue. Then here at port F, I'll be displaying the second hourly, we can say the unit hour, and then similarly at port D will be showing the minutes, and for those again 0 till 10, and then for the second tens of the minutes, we again 0 till this loop will go from 0 till 6 because we have 60 minutes. So basically it will go from 0 till 5, and at 59 we will move towards there will be an increment in an hour variable. Okay, so that's why it will run only 6 times. And then simulate the seconds. We have the port B and A. For that, A will change its value after every 1 second, and which will be the unit of the second segment, 7 segment, and then the tens of the 7 segment of seconds will also run till 5. At 59 it will change its minutes value. So similarly, so after creating all these nested loops, for loops, let's run this. So it is a Proteus file, simulation file, and all of these 7 segments are on the ports which are defined. And let's run this. You can see all the values are now. Second is 1, and after each second this value of seconds will change, will increment, and we will see. After 9 we can see the seconds have again go to 0, and this tens of seconds has gone to 1, and similarly this will continue for as a watch behaves. Now this is our code for Hex Keypad. We will be interfacing the Hex Keypad. Whatever we press on the keypad will be displayed on the 7 segment display. For this, the code is, again we have created an array which has the ASCII codes for 0 till 9, and then declared port C as the output, where this 7 segment display is connected. Then we have two variables for temporary variables for row and column. So first of all, we check for all the Hex Keypad, that as you know, Hex Keypad is connected in a row, and here we can see these are the rows and these are the columns. So this works in a way that when here we can see that we take an input at pin B from port B and save in the row. Whenever we get at an instant when we give an input at pin B, it gets saved to the row, and here we can set the row and then in the column. So and then we have given the conditions, as you know, if the row is equals to 1 1, then and if the column is also equals to 1 1, which means basically it is first row and the first column. So basically of the Hex Keypad, it is this element, this value is 7, so which is basically a first row and first column. So if these values are equal, so then we will be displaying 0. Okay, so we'll be displaying one adder, we'll be displaying one adder 7 segment. So see add now moving to the second here we can see if the row is 1 and column is 2. So basically first row second column, so at first row second column we have 8 here. So this will, if when 8 will be pressed, so our row and column values will be 0x12, and this will display 8 on an LCD. Previously I said it would display 1, it will display 7 there. And similarly we have created all all the functions for all the other values and buttons similarly. The numbers of rows and numbers of columns are kept as a condition for what is to be displayed. Similarly, so we have created almost 10 conditions for the 10 numbers. Let's run this. Let's be presses press 5, so we can see that 5 is being displayed on the screen. This video I'll be just looking at a simple 7 segment display and how it works. So let me open the code. Here is a code for the simple 7 segment display of numbers. So here we have created an array in which we have given the ASCII code from 0 till 9 numbers, and created these two output ports B and D, and then we are just simply sending these ASCII codes at the output at port VA, where we have connected a 7 segment display, and we are incrementing the number in the index number of the array, so that